So the first step here is going to be to take the derivative. So I've got r of t here. So r prime of t is going to be 2t and negative t squared. Now the formula for this capital T, remember capital T is the unit tangent vector. So that's going to be this r prime of t vector divided by the norm of the r prime of t vector, right? So remember r prime of t? That derivative is tangent to the curve r of t. But I need a unit tangent vector, so that means I have to divide by that norm. So this is going to be r prime of t divided by square root of 2 squared plus 2t squared plus negative t squared squared. So this would be t to the fourth plus 4t squared plus 4. Yeah, I started at the end. I did the negative t squared squared, and then I moved backwards. Yeah. Okay. So somebody tell me what is, if I wanted to simplify that denominator, what's the square root of that polynomial? Yeah. T squared plus 2 works. So if I had t squared plus 2 and then I squared all of that, then I would get that quartic polynomial under the radical. So I'll go ahead and write the whole thing out element-wise. And so this vector, this unit tangent vector, is going to be 2 divided by t squared plus 2 for the x component. For my y component, I'm going to call that 2t over t squared plus 2. And for the z component, I've got negative t squared over t squared plus 2. Okay. So one thing I know is that this r prime of t norm is something I already took. This was just t squared plus 2. So I know the denominator of my curvature. So over here I can write k equals t prime of t, oops, yeah, norm, divided by t squared plus 2. Now I just have to find t prime of t and then take the norm of t prime of t. So t prime of t just means I take the derivative of every element here. And so this is going to require us to use the quotient rule 3 different times on 3 different quotients. So this is going to be a vector where the first component, you think about derivative quotient rule for 2 over t squared plus 2. So it's going to be negative 2 times 2t divided by t squared plus 2 squared, I think. so correct me if I'm making mistakes, but in my head I'm thinking f prime g, which would be 0, minus f g prime, which would be minus 2 times the derivative of my denominator, all divided by my denominator squared. And then for this one, I have, let's see, f prime g minus f g prime all over g squared. And then let me extend this a little bit so I've got more room. And then for my last element, the z component, down here, I have f prime, which is negative 2t, times g minus f, which is negative t squared, times g prime, which is 2t. Again, over g squared. So that is t prime of t. And again, for the numerator of my curvature formula, what I need is the norm of t prime of t. So the norm means you square everything, and then you add them all together, and then you take the square root. Yeah. So this is going to get really big and ugly, but, you know, let me write over here. The norm of t prime of t is going to be the square root of each one of these elements squared and added together. So whenever I square each one, you know, if it were negative, then it would be positive. So like for this, I don't have to worry about the negative in the first element here. And I can just write, you know, 4t over t squared plus 2 squared, all squared, plus, and then here, I'm trying to simplify the orange bit, right? And so I see 2t squared here, and then minus 4t squared. So that'd be like negative 2t squared plus 2 divided by t squared plus 2 squared, all squared. And then, for my last component, I've got negative 2t cubed plus 2t cubed, so the t cubes cancel, and so this is just negative 4, but the negative doesn't matter, so I can write plus 4 over t squared plus 2 squared. And then, of course, remember to square the whole thing. And that big nasty expression, that is the norm. So that's going to be the denominator of my curvature formula. There's probably some more simplifying we could do. So notice after I square all of these, you know, if you're squaring something, you can just square the numerator and square the denominator. And since these all have the same denominator, after I square it, they'll still all have the same denominator. And so here the denominator will be t squared plus 2 squared squared is to the 4th power. And then I'll end up with 4t squared plus negative 2t squared plus 2 squared plus 4 squared. So that's like 16t squared over here. And then we probably want to expand out this middle part that says negative 2t squared plus 2. So that's going to be 4t to the fourth sorry, I'm going to rewrite this whole thing so I have more room again. 16t squared plus 4t to the fourth minus 8, right? Minus 8t squared plus 4 plus 16. So plus 4 plus 16, that should just give me plus 20 for my constant. And then I have a 16t squared minus an 8t squared, so that's just going to be an 8t squared when I add those and collect like terms. So I can write 8t squared plus 4t to the fourth plus 20. Okay. So that was the... Oh, I think I misspoke earlier. I said it earlier was the numerator. It was actually the... Sorry. I'm not speaking right now. I said earlier that that was the denominator of the curvature. That actually is the numerator of the curvature right there. That was my norm of t prime of t. And so all I have to do to get the curvature now is write that expression divided by t squared plus 2. And if I wanted to move that inside this radical, I could think of this as the square root of t squared plus 2 squared. And then whenever I move that inside the radical, that just becomes a 6 instead of a 4. And so something like that is my curvature. Okay, so curvature is not easy to calculate. This was one of like the easier examples you could come up with, and even then it's like 10 steps and they're all really nasty steps, just in terms of algebra, right? None of this is difficult calculus. All of the calculus is quotient rule at the worst, but just the algebra is tedious. Okay. So let's do one more example, and then we'll call it a day, and we'll move on to homework questions. So, if you were given this example, I have this function y equals x minus 1/4 x squared. So I can think of this as a parametric curve if I were to just write r of t is equal to t for x, and then for y, I could write t minus 1/4 t squared, and for z, I could write 0. Since my z is a constant 0 value, that places the whole parametric curve in the xy plane. And you can see how this is equivalent. If I just set x equal to t, then I could, what do we call it, eliminate the parameter. Just replace t with x, and then that's how you get your equation for your y coordinate. And so this is the same. And now I can just do the same comfortable old procedure that I would normally do for curvature, right? So we've memorized that curvature is just t prime of t norm over r prime of t norm. So r prime of t is going to be just the derivative, and so that would be 1 comma 1 minus 1/2 t comma 0. And so this norm is going to be just square root of 1 squared plus 1 minus 1/2 t all squared. So that's square root of 1 plus 1 minus t plus 1/4 t squared. Again, stop me if I'm making any mistakes, but I'm just going to rewrite this as square root 1/4 t squared minus t plus 2. I'm going to take the 1/4 out of the radical, and I can do this by saying, well, 1/4 is kind of the same thing as 1/2 squared, and that makes this t squared. But then I have to multiply my other terms by 4 as well, so I say minus 4t plus 8. And that's not a perfect square, so actually I can't simplify that anymore, I don't think. No, okay. So that is going to be the denominator in my curvature equation, right there. And I also need that to find my unit tangent vector, t prime of t. So this is going to be r of t divided by the norm of r of t. So my unit tangent vector is going to be this vector, 1 divided by 1/2 square root t squared minus 4t plus 8. The y component is 1 minus 1/2 t divided by 1/2 square root of t squared minus 4t plus 8. And then the z component is 0. I can simplify both of these by just multiplying the numerator and denominator by 2. Right? If I want to cancel that 1/2 in the denominator, I could just multiply the top and bottom by 2 to keep it balanced. And so this becomes 2 over that radical. And then this would be 2 minus t over that radical. Oh, yeah. So I made a big mistake here. My big mistake, and thank you for catching it, is right here. That's not the formula for the derivative of t, that's just the formula for t. Yeah, my bad. So thank you for catching that. Yeah, very important. So yeah, I actually need to take the derivative, which is going to make this even uglier. But thank you for catching that. That's important.
Just pretend like it is.
I would have totally missed the points on this question. Okay. Yeah. So perfect. We found now capital T. We still have to find what is t prime of t.
So multiplying by 2, it's gonna make 2 times t. It's not t. If you multiply the initial vector found, the unit vector, by 2, it's going to be 2 unit vectors.
I didn't multiply the unit vector by 2 though. What I did is for each component I multiplied the numerator and the denominator by 2. So I multiplied by 2 over 2, which is multiplying by 1. Yeah. Okay, so now we're ready to do this again. And we're doing quotient rule, right? Quotient rule for derivatives. And I'm thinking to myself, okay, f prime of g is 0 minus f g prime, which is going to be the derivative of square root of all that junk. And so the derivative of square root is going to be 1/2 times this polynomial to the power negative 1/2. And then, so that's minus f g prime. Oh, times, don't forget chain rule, the 2t minus 4. Okay. divided by g squared, which is actually nice. It's this. Okay, and then the second component here is going to be f prime, which is -1, times g, which is the square root of t squared minus 4t plus 8, minus f, which is 2 minus t, times g prime, which is 1/2 t squared minus 4t plus 8 to the power of -1/2 times 2t minus 4. All over t squared minus 4t plus 8, and then my c component is 0. Okay, now we have to take the norm of all of that mess. So the norm now is, of course, the square root of those things squared. So this 2 and this 1/2 are going to cancel, so that goes away. Since this whole numerator is just negative, whenever I square that, the negative isn't going to matter anymore, so I can actually ignore the negative. And if I just think about squaring the first thing right now, I'm not going to be super picky about simplifying on my first try. So I'll do t squared minus 4t plus 8. Of course, it's squared, so that 1/2, that -1/2 power becomes a -1. And then this is 2t minus 4 squared over t squared minus 4t plus 8 all squared. Okay, plus, now I have to square the second component. In the second component, I notice again the numerator is all negative terms, and so I can forget that and just call it positive because I'm about to square it, and so a negative squared makes a positive. And however, I can't be too reckless here, so I have to say t squared minus 4t plus 8 plus 1/2 2 minus t times t squared minus 4t plus 8 to the power -1/2 times 2t minus 4 close parentheses squared over, actually it would be the same denominator, and so since it's the same denominator, what I should really do is just something like this. Okay. So whenever I take the square root of all this, of course I can unsquare the denominator, and that would just be what it is. There may be some way to simplify the numerator, but it's super messy. So here's how I'm going to sum up what we're doing right here. So remember that once you're done, the curvature is what? T prime of t norm divided by r prime of t norm. We've already found r prime of t norm. We've already found t prime of t norm, even though it's not super simplified right now. The way I'm going to ask you this question on an exam, if I ask you this question on an exam, right? But the way I would ask it is probably not just to tell me the formula for the curvature, but probably what I would ask is like, what is the curvature at t equals 1? And in that case, rather than simplifying all of this, you could just plug in t equals 1 and start getting numeric answers. And numeric answers simplify really fast, right? So you don't have to deal with all of the drudgery of all the algebra, right? You can just start replacing t with 1, and figure that out faster. So, if I asked you the question, what is the curvature at the point t equals 0? We could go back here and say, well, just replacing t with 0, that makes things a heck of a lot easier, right? So this whole big ugly expression is just 8 to the power negative 1 times negative 4 squared plus the square root of 8 plus 1/2 times 2 is 1 times 8 to the power negative half times negative 4, that all squared, divided by 8 squared is 64, right? So if I give you t equals 0, look how easy that was to just plug in t equals 0, and then now these things start simplifying really fast, right? So continuing, this would be 4 squared is 16, divided by 8 is just 2. And then I have square root of 8 plus 4, well, no, I should say minus 4. Minus 4 divided by the square root of 8, all squared, divided by 64. Oops. And squaring that second bit is going to give me 2 plus 8 minus 8 plus 16 over 8. Correct me if I squared that incorrectly. So 8 squared is 8 minus 2 times 4 times square root 8 over square root 8 is minus 8. And then plus 4 squared over square root of 8 squared. Yeah, I think that's right. All over 64. And then that's 2 plus 2, that's 4 over 64, which is 1 over 16. 1 over 16. So, okay, so what we just found is that, going back to my curvature equation, this norm of t prime t is 1/16. Okay, what about r prime of t? What if I plug in t equals 0 to my r prime of t equation right here, right? This is what we're looking at. If I say, what if t is equal to 0? Well, if t is equal to 0, this is 1/2 times square root of 8. And that would be my curvature. Right? Multiply the top and bottom by 2, and I would get 1 over 8 divided by square root 8. And so that's the same thing as 1 over 8 root 8. So I can multiply the top and bottom by square root of 8, and I would get something like square root of 8. Actually, no, let me try to do this better. So square root of 8 is 2 root 2. Now multiply the top and bottom by root 2, and this would be 8 times 4, which is 32. So that's the curvature of this curve at the point t equals 0. And t equals 0 means x is 0. So at the point x is 0, we have curvature, what did I say, square root 2 over 32? Yeah, 32. So what is my radius of curvature? Radius of curvature is this 1 divided by k, right? So that should be 32 over root 2. Or you call it 16 root 2. it has radius 1 over k. Where is the center of the circle of curvature? Well, the center of the circle of curvature would be if you have this curve, I'm going to call it r of t. And this point along the curve is the point, call it t0.
It's going to be the radius times the normal vector, giving the position vector of the...
Exactly. Yeah. So this vector is going to be my capital T of t naught. This orthogonal to the tangent and pointing in the direction in which the curve curves, that is my principal unit normal vector at the value t naught. Now the center of the circle of curvature is this. If you start at this point on the curve and then you go in the direction of the normal vector, the distance r, that's where the center of your circle should be. So if I were really good at drawing, I could draw like a really nice circle here, centered at point C with that radius r. But that was really sad. It started off good, and then it started to be less good towards the end there. Okay, so something like that. What I'm trying to say is you start from that point along the curve, so you need to know the coordinates of that point at the value t naught, and then you add to it r times the principal unit normal vector to get the new coordinates of the center of the circle of curvature. So make sure, does everybody feel like you understand what I mean with this picture?
What do we have to add to get the coordinates to the center?
Okay, so I'm going to call C the center, right? So the center of my circle is a vector, right? The center of my circle is a vector. To get the center of the circle, I have to get the point on my curve, which is the vector r evaluated at the value t naught, plus, since I'm using r for radius, I should actually be smart and use a different letter for my curve. So let's say that my parametric curve is now p of t. Here's p of t. So that's the point on my curve, plus r times n of t. So just to be super clear about this, the center of your circle is a vector. It's got x, y, and z coordinates. This position along your curve is a vector because it has x, y, and z coordinates. This principal unit normal vector is a vector. It's got x, y, and z components. This is the scalar that is the radius of curvature, right? Oops. So remember, r equals 1 over k.